Hello, welcome to another episode of Automation Digest. Last session we discussed about Singleton and we discussed how we can break Singleton using reflection. But then, can we save it? Yes, we can. So we'll discuss how we can save Singleton from reflection. We'll also discuss about other variations using which we can break Singleton and ways to protect Singleton against them. We saw that using reflection, we were able to get the constructors and post that we were able to set accessibility as true, which means even though we were having the constructor as private, we were making it accessible from outside the class and creating the new instance. Now, what if inside the constructor we put a check? If there is no object, we would be allowing a creation of new object, else we will not allow that. That will protect singleton from reflection, right? So let's do it. There are other ways of saving singleton against reflection by using enum instead of creating a singleton class. We can create an enum of singleton where we can pass the instance itself. Enum internally makes sure that the instance is created only once. Now, because enum is package private or private access, we cannot call a constructor from outside the enum, which means it directly saves us from against reflection. Either of the way works fine against reflection. Let's try to implement both of them and see the results. Before that, if I execute this quickly, we will see the use case where reflection breaks singleton. There it is. Instance number 3 is different. Our intention over here is either not to get the instance 3 created or throw an exception whenever we are trying to do that. The first way that we talked about is inside the private constructor, we can check for the instance, and if it is not null, we can throw a runtime exception. If I run this code this time, if you observe, only 2 instances was created, which was by the normal process of using the get instance method. For instance 3, we got an error. The first error that you see says about the runtime exception which was there inside the private constructor, followed by the null pointer exception because the instance in line number 7 was null, which we were assigning after using the reflection. Now, because reflection was not able to assign an instance to this variable, we were getting a null pointer exception. Eventually, we protected singleton against reflection. Now, we can also use enum instead of this. To implement enum, let me comment out all the sections of code which is not needed. So I do not need this method. I also do not need this part of the code. I won't be using the method here. All right. Now let's create an enum called singleton and have a variable, let's say instance. Now, if I try to instantiate this instance variable and use the hash code to see if it uses the same object or a different one. Let's write it 4 times. If I execute this code, to our surprise, all the 4 execution will have the same value. And line number 12, where we were trying to create the reflection, it fails automatically because we are not able to create enum objects using reflection. So these are 2 ways with which we can save singleton from a reflection attack. There are other ways by which singleton can be broken. One of that is serialization. Serialization means converting the object into byte stream. The byte stream is saved in the file and sent over the network. When we deserialize that object, it creates a new instance, hence breaking the singleton pattern. Let's write that code to understand how that serialization works. Let's say I've created this instance 2 and I want to create the instance break from this instance 2. Let's see what happens using serialization and deserialization. So I have serialized the output stream to the file called file.txt and deserialized it from the same file to create the object. Finally, let me just implement serializable here and let's execute the code. We will see that instance 3 now has a different value. That's because we were able to create a new object using serialization and deserialization. To protect the serialization, what we need to do is just implement one method called read resolve. So if I have a method called read result and call get instance method from inside read result, that should do the trick. Let's execute this again. This time we see all the three has the same value even after serializing and deserializing the object because of read resolve method. So for our singleton to be serialization attack proof, we need to add this method called read result and return the method which we were using to create the singleton object. Apart from this, we have another problem, which is cloning. If we clone the object, we would be able to create a new instance or break the singleton. How do we do that? We create a class which implements clonable, where we have a clone method which calls the clonables clone method. And whenever we are calling this clone method from our main, we will be able to create a clone of the object, meaning a different object altogether. Let's do that first to understand the problem, and then we will protect our singleton against clone as well. To start with, let's create a class called superclass, which implements clonable. We will have a clone method, and now let's extend the superclass in our singleton class. Now let's clone this. I will use the clone of instance2 and assign it to my instance break. Now, if I execute this code, if you observe, the third instance or the instance break now has a different value, which means it has broken our singleton. To overcome this attack, we can override the clone method in our singleton class where we can throw an exception. And now if I execute this code, we will see that we are not able to create a clone in line 25, where we were actually trying to create the clone from our test instance too. So now clone is no more supported, which means we are again safeguarding our singleton against clonable. But we were not even getting our object created. So instead of throwing the exception, we can return or call the method which was creating our object. If I return the get instance method, it would indirectly be checking if there is an object present, and it will return that object. If not, it will create a new one and return. In any of the cases, it will have only one instance at any given point of time. If I execute this code, I'll get the same object because it was created in step 1 for instance 1. Every other instance will just follow the same object which was created during the program. So now our singleton is reflection, serialization, and clonable protected. We can use the singleton implementation where we will have one single object throughout the program, safeguarding against all the possible attacks against singleton. That marks the singleton design pattern to be complete. I hope you liked the video. Thank you for watching. Stay tuned for more such videos. Happy coding.